Hello everyone, this is Pritika Mehra, Assistant Professor, Postgraduate Department of Computer Science, Khalsa College for Women, Amritsar, going to deliver a lecture on data warehousing and online analytical processing. Let's start with what is a data warehouse. A data warehouse is a subject-oriented, integrated, time-variant and non-volatile collection of data in support of management's decision-making process. It's a decision support database that is maintained separately from organizations' operational databases. It supports information processing by providing a solid platform of various other transactions such as that are used for analysis. Data warehousing is a process of creating and using the data warehouses. Next comes the characteristics of data warehouse. There are 4 characteristics of data warehouse that distinguishes them from other operational repository systems such as transaction databases, relational databases, flat files, etc. Now these characteristics are subject oriented, integrated, time variant, non-volatile. First of all, what is a subject oriented? Subject oriented means that data warehouse is organized around various subjects such as customer, product, sales, item, etc. It provides a simple and concise view of various subjects which can be used to analyze the data. Next is integrated. Integrated means that data warehouse is constructed by integrating various data sources. The data sources are heterogeneous and are in various different formats. So these data sources must be converted into a data warehouse format. The data warehouse format can be done by using the data integration, cleaning, transformation tools. So data cleaning and transformation tools, when applied to the data sources, they convert the various data sources which are in different formats into a data warehouse format. Next comes the time variant. Time variant means that the time horizon of data warehouse is longer as compared to operational databases, because operational databases, they depend upon current value data, whereas data warehouse depends upon the past historical data, which is usually 5 to 10 years. So time variant helps to have a time element in each key structure of data warehouse, but this is not a requirement in operational databases. Operational databases may or may not have a time element. Next comes non-volatile. Non-volatile means a physically separate store of data which is transformed from operational environment. Data warehouse does not require any operational updates because it is based on current value data. No transaction processing, no recovery, no concurrency is required. Whereas operational databases, they require concurrency control, transaction processing, recovery, etc. Data warehouses, they do not require any current data. So we require a non-volatile collection of data. Next is, why do we need a separate data warehouse when we already have operational databases? The answer to this question is that the data warehouses are required to achieve high performance of both the systems, that is for databases, that is operational databases, and data warehouses, because both the systems, they are tuned for different works. That is, operational databases, they are tuned for online transaction processing, recovery, concurrency, but data warehouses, they are tuned for online analytical processing. Access methods used in online analytical processing are different from databases. Therefore, to achieve high performance, we require a separate data warehouse. Also, there are several differences that exist between a database and a data warehouse. A database, they have limited number of users. Data warehouse have different types of users like managers, knowledge workers, etc. The functionality of data warehouses is different from that of operational databases. Operational databases, they work on current up-to-date data, but data warehouses, they work on past data. So due to the differences, we require separate data warehouses. Next comes the architecture of a data warehouse, which is a 3-tier architecture. The 3-tier architecture consists of bottom tier, middle tier, and top tier. Bottom tier contains various data sources that are heterogeneous, as I have already told, and the data sources, they contain different formats. So data extraction, data loading, Data cleaning, data transformation, data integration, and finally refreshing is required to the data sources in the bottom tier. Next is the middle tier. The middle tier consists of data warehouse, which is constructed after integrating the data collected from multiple heterogeneous data sources. Data warehouses, they can be split into subset of databases known as data marts. Middle tier also contains metadata, which is data about data. And in the middle tier, there are Olap servers also, which are required to process the data stored in data warehouse and analyze the data. Finally, the top tier, it consists of various front-end tools like that are used for querying, reporting, displaying results, presentation, visualization, etc. The front-end tools are tables, charts, graphs, etc. Next comes the three models which are available for data warehouses based upon data warehouse architecture. There are three models of data warehouse based upon the architecture. These models depend upon how the data is collected. So there are three categories. One is enterprise warehouse model, second is data marts, and third is virtual warehouse. Enterprise warehouse consists of collection of information about subjects spanning the entire organization. But data marts, they are subset of data warehouse. Subset of data warehouse is required when we have large organization and small departments are there. So each department can have its subset. So subset of corporate wide data helps to analyze only the specific set of data. So it focuses on the specific group of users. Then we have virtual warehouse. Virtual warehouse consists of various views of data warehouse. Now there can exist several views of data warehouse, but all of the views, they may not be useful for the organization. Therefore, only some of the views will be used for the organization, and they can be materialized for the virtual warehouse. Next comes the multidimensional data model. The multidimensional data model of data warehouse consists of a data cube. The data cube is different from the mathematical cube which we use in mathematics, but here in data warehouses, the data cube consists of dimensions and facts. Dimensions are the entities of an organization. These dimensions are represented by dimension table. For example, let's take an example. For example, we have customer, then we have employee, then we have product, branch, item, time. These are the entities. Then we can have dimensions, dimension tables for each of these dimensions. The dimension tables are represented by tables, and finally they can be converted into various other structures like 2D cubes, 3D cubes, 4D cubes, and ND cubes. Similarly, we have facts. Facts are the numerical measures. Numerical measures for calculating the values by aggregating the data, that is for calculating the amount of products sold, units sold, etc. For example, we can have, if we want to calculate, suppose we want to calculate how much amount is spent or how much amount is spent for particular item, then we can have a fact table for that. And in the fact table, there are various attributes. Along with the attributes, there is one special attribute that is known as key ID. Also in dimension table, we also have key IDs. Now, we can have ND cubes and we can have 0D cubes. What this means that 0D cube means summarization, ND cube means low level summarization, ND cube means higher level summarization. So ND cube is also known as apex cuboid and 0D cube is also known as base cuboid. Now, after having the cuboid, we can have a lattice of cuboids which are basically known as data cubes. Based upon the multidimensional data model, there are three types of schemas which are used to define or design the architecture of the data warehouse. The three schemas are star schema, snowflake schema, and fact constellation. What is star schema? Star schema consists of one central fact table around which there are multiple dimension tables. So how the dimension tables are connected to fact table depends upon the key ID. We have a key ID in each of the dimension tables. These key IDs, they are connected to the fact table. Fact table will have key IDs of all the dimension tables along with its own measures such as amount sold or unit sold, etc. Snowflake schema. Snowflake schema is same as star schema, but how it is different from star schema is the fact that the dimension table can be split into sub-tables or sub-dimensions or sub-dimension tables known for normalization. That is, for normalizing the dimensions, we can split the dimension table into various subtables using the concept hierarchies. For example, if we have a location hierarchy, then location concept hierarchy can be split into subdimensions like we have country, country can be split into state, state can be split into city, street, etc. Then we have fact constellation. Fact constellation consists of many fact tables. So now in star schema and snowflake schema, we have only one fact table, which is a central table around which there are various dimension tables. But in fact constellation, we have we can have various fact tables around which various dimension tables can be connected, and the connection can be done with the help of key IDs. Now in fact constellation, again, normalization can be done or it cannot be done. If normalization is done, then it is a part of snowflake schema. If normalization is not done, then it is a part of star schema. Now next comes OLAP. What is OLAP? OLAP stands for online analytical processing. Why is it important? It is important because it is an important concept for data warehousing. OLAP helps to analyze the data. So what are OLAP servers? OLAP servers are software tools which helps to analyze the high dimensional data at a very high speed. We have several OLAP servers available: ROLAP, MOLAP, HOLAP, and specialized SQL servers. First of all, what is ROLAP? ROLAP stands for Relational Online Analytical Processing. Now, relational online itself explains that there will be relational database or extended relational database which is created and maintained at OLAP servers. Next is MOLAP. MOLAP stands for Multidimensional Online Analytical Processing. Multidimensional online analytical processing is used for multidimensional arrays because in high dimensional data we have sparse arrays. The sparse arrays cannot be maintained by relational databases. So for sparse arrays, sparse high dimensional arrays, we can say we require multidimensional array structures. These multidimensional array structures are created and maintained in MOLAP servers. Next comes HOLAP. HOLAP stands for Hybrid Online Analytical Processing. Now, hybrid, as the word says, it is a combination of ROLAP and MOLAP. So, this means it can handle relational databases as well as multidimensional sparse arrays also. So, both the things can be combined together in HOLAP servers. Next is specialized SQL servers. Specialized SQL servers are those servers which can handle simple SQL queries, because in data warehouse we handle complex SQL queries. So these are specialized servers for handling SQL queries. Special SQL servers are maintained. Next come OLAP operations. There are various OLAP operations which are used for analyzing the data. The multidimensional data model which is created for the data warehouse is analyzed by OLAP operations, using OLAP operations. There are several OLAP operations like slicing, dicing, drill down, roll up, pivot, etc. First of all, what is roll up operation? Roll up means that climbing up the hierarchy. Climbing up the hierarchy means summarizing the data. Summarizing the data by reducing the dimensions. So in this operation, we reduce the dimension. It is also known as dimensional reduction or dimensionality reduction. Then is roll up, or we can say drill down. Drill down means not climbing the hierarchy. It is reverse of roll up. That is, it means adding the attributes, adding the dimensions. So it is the increasing of dimensions in the data warehouse. Next is slice. Slice is same as projection operation which we use in SQL. Slice means that selecting particular attributes while displaying the results of the query. Then is dice. Dice is similar to selection operation which we use in SQL, and it means selecting particular records depending upon the given condition. The records which satisfy the condition, they will be displayed. The records which do not satisfy the condition will not be displayed while displaying the result of the queries. Last operation is pivot operation. Pivot operation means rearranging or reorienting the structure of the data warehouse. That is, if we have a 2D table, then 2D table can be, in 2D table, rows can be swapped to columns and columns can be swapped to rows. Similarly, we can have a 2D or 3D cube. If we have 3D cube, changing the orientation of the 2D or 3D cube can lead to pivot operation. Last, why do we use data warehousing? What is the usage of data warehouse? So the most important data warehouse usage is information processing. So it processes the information. Analyzing, it helps to analyze the data, and most important concept which we can give is data mining. Data mining means extracting knowledge from the data which we have collected in the data warehouse. When we have once collected or designed or constructed the data warehouse, then that data can be used for extracting various patterns, various different types of knowledge from the data warehouse data. So that's all. That's it. Thank you very much. Have a nice day.